Greetings, Year 13s. Here we are looking at the differentiation of trig functions. And so what I've done to start off with is draw out the trig functions. So here we have the graph of y equals sine x, and we're going to consider the gradient at different points. So with any curve, where you've got a point at the top of a graph, you tend to have a turning point, and at the top of that turning point you have a gradient of 0. So if I tracked down that point here and said that this graph I'm going to draw out the y dash, so the gradient of function of sine, if that gradient there is 0, then I'd be putting my first point here at 0. If I look at this point here as well, my gradient is also going to be 0 there. So I want to think about where my maximum gradient occurs, and my maximum gradient is going to occur at this point here. So it's going to start at positive 1. Our rise over run will be at positive 1, and my lowest gradient will be at this point. So if I track that down, that will be negative 1, going down by negative 1, and then the gradient increases again at this point, and we're back up to positive 1. So if I sketch out those points to form a graph, what I find is I'm left with the cos graph. So I can say that sine differentiates to cos of x based on the gradient function. Okay, so let's see if we can do the same with cos x. So here's the graph of y equals cos x, and we'll do the graph of y dash underneath. So let's look for the maximum and minimum points first. So here's a maximum point, so the gradient will be 0. Here's a minimum point, so another 0 there, and here's another maximum, so 0. Okay, at this point it's decreasing at its most, so that will be negative 1, and at this point it's increasing, so that will be positive 1. And so if I sketch those points together as a trig function, I get this graph here, which looks a little bit like our sine graph, except you'll notice that it's flipped around the other way. It's actually negative sine. So we can say that cosine differentiates to negative sine x. Okay, so we're going to look at one more function, and that's for tan. And here I've drawn out the tan graph, and so that's y equals tan x, and I'd like to draw out what our gradient function is going to look like. So like with the other graphs, we started with the lowest gradient, and the lowest gradient occurs here, and it might be quite easy to assume that the gradient goes to 0 there, but it actually never goes to 0 in tan. If you look at the graph very closely, it doesn't go to 0. In fact, the gradient at that point is around about 1. And I should try and draw it a bit closer to get an effective scale. So here as well, our gradient is going to be positive 1, and here our gradient is going to be 1 as well. Now another interesting thing about our tan graph is no matter where you look on the graph, anywhere, the gradient is always positive. So our graph is not going to go into negatives at all. Anywhere, absolutely anywhere, the graph is always positive. The only thing is, it varies from a positive we can measure through to a positive that we cannot measure. Now the asymptotes are going to be important as well, so I'll draw in the asymptotes, and I might just get rid of those lines to make it easier to track. So let's put in our asymptotes here, and our asymptotes are significant because our gradient is going to approach those as well. So our gradient for the first bit is going to look like that, and here our gradient is still positive, though it's decreasing towards 1, but then it increases again back up to the asymptote, and then it comes around again, and I'm sure you could guess that it would just cycle through that indefinitely. And that graph there gives us, and I'll just show on the table here, sec squared x. And so the derivative of tan, the graph that is the derivative, or the gradient function of tan, is the same as sec squared of x. Okay, so quite an unusual graph. If you want to graph that on your calculator, you'll need to exchange sec for a function that will work on your calculator. So that's one way of describing our trig function derivatives, by drawing out the graphs and plotting their gradient functions. And that's the easiest way to explain why they differentiate to those functions. And that's where I'd like to leave this video.